Question number 3. The standard 6-sided dice is rolled twice. Which of the following events has the highest probability of occurrence? So since the dice is rolled twice, if you want to write down the total sample size by constructing a 6 by 6 table and find out all the 36 outcomes, it's all right. However, I do not find the need to do that because the question is not that challenging. However, if it makes it easier for you to understand, I suggest you to draw a 6 by 6 table and write down all the possible outcomes of these events. So let's go ahead and start with answer choice A, which says the second number is twice the first. So there's only 3 outcomes if the second number is supposed to be the twice. So my first could be 1, followed by 2, 2 followed by 4, and 3 followed by 6. So it matches the description here. That means the possibility of this happening is 3 over 36, which is my sample size. For part B, we have to find out the probability of the second number. We have to find out the probability when the second number is not greater than the first. So this one might be a little bit lengthy because you should start with taking the first one to be 1. So that would be, and keeping it fixed, and then vary the second outcome. So that would be 1, 1, 1, 2, 1, 3, all the way to 1, 6. And that's a total of 6. And then moving on to 2, that means the first dice to be 2, followed by 2, and then 3, and then 4, all the way to 6. So that's a total of 5. Before I continue, I want to remind you that it says shouldn't be greater than. It doesn't says anything about being equal. That's why 1, 1, 2, 2, and 3, 3 is acceptable all the way to 6 and 6. So if you just count them up, you get 6 outcomes when the first dice is 1, 5 outcomes when the first dice is 2, 4 outcomes when the first dice is 3, using the same pattern all the way down to getting a 6, 6, which is only one possible way. So therefore, if you add up all these numbers, you get nothing but 21. Therefore, the final answer is 21 over 36. Now for part C, what's the probability that at least one number is greater than 3? That's going to be a lot of cases which match this description. So I rather to look at the question the other way around and count those cases where everything is 3 or less than 3. Because here it says greater than 3, that means 4 and above. So I'm going to go with 3 and below. So that means 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2 and 2, 2 and 3, and 3 and 1, 3 and 2, 3 and 3. So that's a total of 9. But this is what I don't want. So knowing that its probability is 9 over 36, you just have to subtract it from 1. And that's going to give you 27 over 36. So the probability for this part would be 27 over 36. And for part D, we're supposed to find the probability that the sum of the two numbers is a prime number. Now I have listed all the possible prime numbers that we could get, given that the biggest number on a dice is 6. So the maximum number we could get is a 12. And that means the maximum prime number we should be expecting out of these two dices is 11. So how can we get a 2? There's only one possible way to get a 2. That's 1 and 1. For 3, we could get 1 and 2 or 2 and 1. For 5, it's a 2 and 3, 3 and 2, or 1 and 4 and 4 and 1. For 7, it's 5, 2, 2, 5, or 3, 4, 4, 3, and also 6, 1, and 1, 6. For 11, we have 2 possible ways to achieve that, and it's 5, 6, 6, and 5. And if you count everything here, that's going to add up to 15. So the probability for answer choice D is 15 over 36. And since they asked for the greatest probability, it's going to be answer choice C, which is 27 over 36. And that's the final answer.